doing 1b from section 7.2. So this integral's in terms of z, but it doesn't matter. We're still going to do our substitution the same way. In this case, we see what's under the radical is 4z squared minus 5. That's what our u is going to be. Du, the derivative of that, is going to be 8z, and then dz. The derivative of the minus 5, of course, is 0. So I notice that I've got a z still and the dz, but I don't have an 8 there, so I'm going to go ahead and divide by 8. I get 1/8 du is equal to z dz. So when I see the z and the dz together, I know they're going to become that 1/8 du, so I'll take the 1/8 and put it in the front. I've taken care of the z and the dz, that became the 1/8 du. What's left is that square root, in this case, is square root of u, and the du, the 1/8 du and the du go together. So from here I can rewrite this as power function, u to the 1/2 power. Separate that. Du, use the power rule on that, so I'm going to just keep the 1/8 in front. I'm going to put my u, raise that by 1, that becomes a 3/2 power. Flip that over in front, I get 2/3 plus my constant. Now I can go ahead and multiply these. The 8 and the 2 can cancel here, become a 4 down there. So what am I left with? I'm left with just a 1 in the numerator, 4 in the denominator times that 3. So I'll have 1/12 u to the 3/2 plus the constant. And lastly, let's go ahead and replace that u back with what it was. It's 4z minus 5. And that's raised to the 3/2 power plus our constant. And so that should do it.